Good afternoon. My name is JKashaija, and today I will highlight one key insight from our utility forecasting project: how missing building data affected our ability to model and predict electricity and water usage at UNCW, and why improving data quality is essential for accurate budgeting. Our forecasting models rely heavily on building characteristics such as size, age, and building type because these variables strongly influence energy and water consumption. However, the dataset contained missing construction years, missing square footage, and inconsistent utility records. The dataset covers 270 buildings across both on-campus and off-campus locations. However, 36% of these buildings are missing completion year information and 15% lack property gross square footage data. Such gaps in the dataset weaken the accuracy of energy intensity forecasts, which in turn introduces greater uncertainty in budget planning. To address these gaps, I cleaned and reconstructed the buildings dataset using Excel. I researched missing construction years and square footage using public records and online resources. But when information could not be found, we used the imputation and JUMP's informative missing feature. This allowed the models to recognize patterns even when data was incomplete, rather than discarding entire buildings. So now I'll talk about why building characteristics were critical in our modeling process. Once the dataset was complete enough to model, building characteristics emerged as major predictors. We engineered variables such as building age, energy error category, consumption factor, conservation factor, and energy use intensity. The energy use intensity of a building is calculated by dividing its total annual energy consumption by its total square footage. In the boosted tree model, total square footage alone explained nearly a quarter of electric usage variation. The age of a building explained 35% of water usage variation. And here we started to see a direct correlation between a building's size and age with the level of utility consumption, be it electric or water. This reinforces the importance of accurate building data for forecasting. Now let's go over the tools and techniques that we employed for this project. We used Excel for data cleaning, normalizing, and imputation, JUMP software for modeling, and Power BI for visualization. Key techniques included variable engineering, boosted tree modeling to identify key drivers, neural network modeling for forecasting, while at the same time using the informative missing feature in JUMP to capture patterns in incomplete data. These tools were appropriate because the dataset was multi-year, mixed type, and contained irregular missingness. Based on this insight, we recommend two practical steps. The facilities department at UNCW must improve data collection and standardization. Ensure that every building record includes construction year, square footage, and building type. A centralized database with validation rules would prevent missing data or zero-value entries. Our second recommendation is to integrate complete building data into budget planning. Accurate building characteristics will improve seasonal as well as building level forecasts, supporting more reliable annual budgeting, and more importantly, it will drive informed decision making about maintenance and energy efficiency. So, to bring this all together in conclusion, our analysis demonstrated that missing building data, particularly construction year, square footage, and building type, all these had a direct impact on the accuracy of our utility forecasting models. By reconstructing the dataset, applying imputation, and using the informative missing feature in JUMP, we were able to preserve valuable building records and uncover the true predictive strength of characteristics such as age, size, and energy era category. These variables emerged as major drivers of electricity and water consumption, reinforcing the importance of complete and reliable building information. Moving forward, the Facilities Department at UNCW will benefit from improving data collection and standardization. This will enhance the university's ability to forecast utility usage, plan budgets with greater confidence, and make more informed decisions when it comes to maintenance and energy efficiency investments. The bottom line is better data enables better decisions. Thank you very much.